Good morning, Algebra 1. I hope that we're having a great start to our day, but let's talk about math for a moment. So this video, we're going to be continuing on our solving equations journey, except this time we're taking a little bit of a blast from the past, okay? So this video is going to be all about solving proportions and ratios and everything that go with that, okay? Because sometimes there's going to be some variables that are on different sides, and we're going to have to figure out how to be able to solve for one of those variables, okay? So, without further ado, let's get to the video.
All right, today we are going to be talking about ratios and proportions. And by the end of this video, I hope that you're able to, one, compare ratios, but I also hope that you're able to solve proportions. We're going to start with our key concepts of vocabulary. So, a ratio is a comparison between two numbers by division. The ratio x to y can be expressed as the words x to y with a colon, x colon y, and then with that slash, almost like division, x divided by y. Okay. A rate is a ratio with different units of measure, such as price per pound, miles per hour, etc. And a rate with a denominator of 1 is called a unit rate. A proportion is when two ratios are equal. In order to check this, reduce both fractions to the lowest form and check them if they are the same. Another way to check this is to use cross products. If the cross products are equal, then a proportion exists. So let's start off with our first couple of examples. So determine whether the ratios form proportions. Well, here's what I'm going to do. I'm going to do questions A and C and leave you with the decimals because I know that you love decimals. So we have 7/8 and 49/56. Well, I know that these are proportional, yes, because if I do 7 times 7, I get 49, and 8 times 7 gives me 56. So yeah, that works out. And part C, 4/5 and 16/20. Again, that's also going to be proportional, so I wonder if B might not be. So I have 4 times 4 gives me 16. I'm multiplying by the same thing. 5 times 4 gives me 20. So let's go to a couple of solving proportions problems. So I'm going to do A, and I'm also going to do D. All right, so the first thing that I need to do, they said that I could try to solve these proportions by using my cross products. That's exactly what I'm going to do. So what I'm going to do is skinny that up a little bit. I'm going to multiply my 8 and my x, and I'm going to multiply my 12 and my 3. So 8 times x becomes 8x. 12 times 3 becomes 36. And if I were to divide by 8 on both sides, I would end up with a fraction 36/8, but that could be simplified to be 9/2. Okay, that one's not too bad, and part B is pretty much the same. So let's talk about part D. So again, I'm also going to cross multiply. Going to figure out my cross products. I'm going to highlight what gets cross multiplied here. So I can essentially write it out like this. 11 times x minus 1 equals 12 times 2x plus 3. And it's like we're back with our distributive property. So I need to do 11 times x and 11 times y, as well as 12 times x and 12 times 3. So 11 times x is just 11x, and 11 times -1 is -11, equals 12 times 2x becomes 24x, plus 12 times 3 becomes 36, so plus 36. And I'm going to subtract by 36 on both sides because I ultimately want to keep my life and my x's positive. So I have 11x minus 47 equals 24x. I'm going to subtract by 11x on both sides to get all of my x's to be the same. And I know you probably say, Mr. Gerber, what happens if I subtracted by 24x and basically just flip-flop this whole thing? That's also fine. Don't worry about it. So these 11x's go away, and I'm left with -47 equals 13x. Now the last thing that I had to do to try to solve for x in this situation is divide by 13. And ultimately, I'm left with my answer of negative 47/13 equals x. And that's going to be my final answer because that cannot be reduced to any further. All right. So I'm going to finish out with example number 3 and leave example number 4 for you to do if you'd like. Jeff rides a 20-mile trail every Saturday. Let's get zoomed in here. It takes him 4 hours at this rate, or it takes him 4 hours. So I know 20 miles over 4 equals, at this rate, how far can he ride in 7 hours? So I need to keep my time in the same location in the denominator, and I want to know x number of miles. Set up a proportion and solve. Well, we pretty much just did that, okay? So I have 20 times 7, and then I'm also going to have 4 times x. So I get 20 times 7 equals 4 times x. That is going to be 140 equals 4x. If I divide by 4 on both sides, I ultimately end up with 35 equals